All right, if we'll look down here, we have a large right triangle here, and if we call this the x-axis here, we call this the y-axis. We can use this as a big displacement vector from the origin up to this point, and it measured out to be 3.5 meters. Now, we didn't make it 3.5 meters, we just stayed within the blue lines, and it so worked out. Now, if you'll notice, 3.5 meters, 1.75 meters, with a little bit of calculation, we can find out that if this is 3.5 meters, this is 1.75 meters, and this is our angle theta, that's opposite, that's hypotenuse, so the sine of theta is opposite over hypotenuse, which equals, in our case, 1.75 divided by 3.5, which comes out to be 0.5. So the sine of theta equals 0.5. So if we inverse sine that, theta equals, I know this is a little sloppy, but inverse sine of 0.5, you find out that theta equals 30 degrees. Okay, so we have a 30-degree triangle here. This is 0 degrees, that's 30, 90 would be up here. And then, of course, if we took 3.5 times the cosine of 30 degrees, we'd find out that this is 3 meters. It's slightly over, but close enough. Now, when we have vectors, gentlemen, if you'll help me out, I'll be the vector. We have a couple of our assistants here. Let's have one of you, actually, since you're shorter than me, I'll have you do X, and I'll have you do Y. How about that? So, Zach, if you'll follow me over here on the Y-axis, and Alden's going to follow me on the X-axis. Now, from this direction, where she's videotaping, you can see that if I were to take a big, okay, you stay over there, we're recording. If you would take a big light, and you were just shine it this direction on me, just slip it under the door, we'll take care of it. Okay? If we were to shine a big light this direction, you would see that my shadow would end up being where Alden is. If we threw a big light from this direction, my shadow walking would be where Zach is. So that Zach would show the Y component, or how far I move vertically, and Alden would show how far I'm going horizontally. So if I walk along this hypotenuse, gentlemen, ready, go. You'll notice Alden had to walk faster than Zach did because he had to keep with me because I'm mostly horizontal. But if, for instance, I were to try to throw a vector way up there, let's let me do one like towards the window, right? Okay. Notice Zach has to go pretty fast and Alden barely has to move because in that case my walking was mostly vertical. Now let's do something here, and I'm just going to pull out my trusty iPhone here and do a quick calculation. So if I pull out a timer, stopwatch. You ready? You guys stay right with me. I'm going to start here and I'm going to stop there. 2, ready, go. Stop. It says 2.8 seconds. Can we agree that's close enough to 3 to make our lives easier? So if it took me 2.8 seconds or 3 seconds to get there, it took Alden 3 seconds to get to where he was, and it took Zach 3 seconds to get to where he was. So let's do some calculations now. We have 3 dry erase boards to make our 3 journeys more obvious. Okay, so Vivian, come on over here so we can do this a little bit closer. So if I went, my speed is 3.5 meters divided by roughly 3 seconds. Well, Alden, in a second, a calculator. So Alden's speed in the x direction was, this is the easy one obviously, 3 meters, 3 seconds, so Alden went 1 meter per second. Well, Zach, in that same amount of time, his y direction speed is 1.75 meters in 3 seconds, and since that's half, he went 1/2 or 0.5 meters per second. Zach, tell me what 3.5 divided by 3 is.
1.17.
1.17, I'm just going to round that to 2 meters per second. Now, here's the interesting part. You sure about that?
Yeah, but the 1/2 is wrong.
Did I mess that up? What is it?
It's 0.58.
0.58, thank you. Okay. Now, let's take this number, and as a big triangle, this is opposite, this is adjacent. Let's take our cosine of our angle. So, if I take this, which is 1.2 meters per second, times the sine of 30 degrees, and Zach, that gives me
0.6.
which is basically 0.58. Or, if I take mine times the cosine of 30 degrees, so I have 1.2 times the cosine of 30 degrees, and I get
1.
So, it doesn't matter if I take the original vector, find its displacement vector, or I take the velocity and I take the vectors, we always get the same ratio because velocity is a vector just like displacement. Okay, and I ended up doing this because I had a student 2 years ago that was like, how can you prove that velocity is a vector? How do we know that?